An aircraft is flying horizontally at constant speed through Earth's magnetic field as shown. As the location of the aircraft, the vertical component of Earth's magnetic field is 38 micro Tesla towards the ground, okay, as shown here from side or from the above. Distance between the wing tips B and Q it is 68 meter. As aircraft moves through magnetic field is an electromotive force of 0.54 V is induced between the wing tips. Calculate magnetic flux cut by wings at or in a time of 15 seconds. Give unit with your answer. So we know that magnetic flux is phi, and phi can be obtained from Faraday's law, which states that EMF is directly proportional to change in magnetic flux linkage. I choose here to be delta phi only with respect to time. Okay, so we have here EMF and we have the time, but we don't have change in phi, so we simply can rearrange and get the phi. And as I choose here the EMF to be in V and time to be in second, so certainly the unit will be in Weber for phi. Determine area of flux cut by wings. We know that phi is equal to B times A. B is 38 micro Tesla times A, which is needed. This is equal to 8.1 Weber, so we can find the area easily to be. Use your answer to determine V. So here is the plan, okay, and as it cuts the fill lines or the flux, suppose it reaches some position here. So this side moves from the beginning here to this point, makes an area. This area equal to the length between the tips of the wings and the distance traveled. Okay, can make this area dashed like that. Okay, if we have the area which we have just calculated from the previous part and divided by the length between tips of wings, we got this width. Okay, we can then divide this width over 15 seconds, which is the time taken to cut this area in the flux. Hence, we get the velocity. Okay, so V equals area divided by length. This length is 68. This gives us the width, and when we divide it by time, we can get the velocity. Okay, so using calculator, you will get speed to be almost 210 meter per second. Okay, use Lenz's law of electromagnetic induction to explain which of wing tips B and Q is at the higher induced potential. Let me emphasize something. When we have a wire that is moving in magnetic field, okay, so direction is into page, we will certainly have induced EMF in the QB direction. This is the induced current, sorry, in the QB direction using Fleming right hand. If we have motion to right and filled into page, you can uh, use your first finger to be into page, your thumb to be in direction of motion or velocity. Then you will find that your second finger points up. So induced current is up. Okay, this is the induced current. I for induced and I capital for current. And to have a current inside the wire, then the direction will be different from outside the wire. So suppose we have some connection to a voltmeter or whatever in the external circuit, the current will flow as follows. And we know that current flows from positive to negative. But this is in the external circuit. But inside the wire itself, the piece that produces the EMF, it will be considered like a battery. And in battery, okay, direction of current is opposite to that in the external circuit. External circuit, it goes from positive terminal to negative terminal, and inside the battery, it continues to be from negative to positive terminal. So inside the battery, inside the conductor where EMF is induced or is initiated, it is from the minus to positive terminal. But it says, a question says that we should use Lenz law. How we can apply Lenz law here? Again, as the field is into page and we have the movement of the wings to right, from Lenz's law, we should have an opposition to this change, the change of getting to right in the magnetic field. We should have an opposition to it, so we should have a backward force. Okay, this backward force is initiated from having a magnetic field produced by induced current. This magnetic field repel with the Earth's magnetic field, so it applies force on wire or on wings to be backward and to oppose the change of moving forward or of moving to right. And if we have a wire with force backwards, okay, magnetic force backward, then we should have a current. So the current should be upward by Fleming left hand. Okay. Why we used here Fleming left hand? Because the output is the force. We agreed together before that Fleming left hand has input of current and field certainly, and the output would be the force, magnetic force acting on the wire. And if we used Fleming right hand like the case here, we will have input to be motion, okay, and B and the output to be the induced current. Here, as we are going to apply Lenz's law, we considered an output of force to be backward. This output of force wouldn't to be applied on the wire if the current direction or if there is no current in the wire. So it is like an inverse Fleming hand problem, okay, where we don't enter with I and B, instead we enter with the output and certainly B to find I. Okay, so the answer will be as there is a magnetic force acting backward on wings, okay, current should be from bottom to top.